Magnitude 6.7 just hit Palu, a disaster zone that has ripped havoc in 2018 with a tsunami and an earthquake. Over 2,000 people were lost. Absolute devastation. Images that look like the Tohoku earthquake and tsunami. Really, really bad. And now that region is hit again with aftershocks right away. So this is not an isolated quake. This is danger zone. Danger and fear of residents that this is just a foreshock for that zone to be triggered again and another devastation. And they have predicted this in 2019. That's why this is so crucial, because what happened in 2019, the headline was the Indonesian earthquake broke a geologic speed limit. A super-shear earthquake on a common kind of fault could raise hazard risks. And now we see this strong earthquake. The geological rupture that was responsible for the devastating magnitude 7.6 earthquake that struck Palu, Indonesia in September 2018, ripped through the Earth's crust at rare high speed. So we need to talk about this because this is a dangerous region. And of course, we look at the current earthquakes and what the devastation is, because you see in the background, I'm showing you the videos that are coming in of what happened. It was a loud quake. It was over a minute long, the shaking, and it was causing damage, as you see in the videos behind me. 2018, Palu earthquake broke the speed limit because the rupture went super shear. That is so important, and I'll explain that to you. That is meaning the fault tear moved faster than normal, shear waves, concentrated shaking like a sonic boom, very, very loud. And that has raised concerns since then that more faults may be capable of this than previously estimated. Not only in this area, I've reported about California. California, there is a new finding that is absolutely doomsday, how we say, territory, especially for Southern California, from LA area down to San Diego. Check that out in the end screen. But let's talk about that sonic boom. Super-shear earthquakes release more energy in less time and can intensify destructive shaking. And this earthquake here was shallow. That's why it was widely felt. Because these quakes can release more energy in a short period of time, so they can intensify destructive shaking. And maybe you have seen my video about Indonesia, about the 7.8 earthquake. Absolutely insane, absolutely insane. And the fault here, the Palu-Koro Fault, is a major left lateral strike slip system, like the San Andreas Fault in a way, that is tied to the 2018 Palu disaster. So now we have the strongly felt shallow magnitude 6.7 earthquake that just hit southeast of Palu in Indonesia. And this is not just any place on the map, as I just said. This is really exactly the same disaster region. That's why we need to explain what that is. And in 2018, scientists thought the ground did something that they once thought, at least, is rare. So the fault rupture moved so fast, it broke the geologic speed limit and became a super-shear earthquake. So the fault was not tearing slowly, apostrophe. It raced toward, like, faster than the earthquake's own shear waves. Faster than the earthquake's shear waves. Let that sink in. I'll explain it. It has forced the energy to pile up in front of the rupture like a sonic boom. And the San Andreas Fault might be able to do that too, by the way. And that's why Palu here is so dangerous. That's why people are so scared right now. It like in a normal earthquake, the rupture moves along the fault line and it sends shaking outwards, yeah? But in a super-shear earthquake, understand that, the rupture outruns part of that shaking. Crazy. So the waves stack together, the energy gets focused, and the ground can be hit harder, faster, and move more violently than it already does, right? That's what scientists discovered after the 2018 Palu earthquake. So 2018 was a 7.5 on the Palu-Koro Fault system, has produced this. I mean, you see the images, right? Catastrophic shaking, landslides, liquefaction, and a absolutely tsunami inside Palu Bay. So, but the shocking discovery came later and the warning came later. So that's why this is scary, what's happening there right now. Some institutes have it even at 6.9. So when the researchers found out that the rupture moved at super-shear speed, it's like a supersonic jet, right? When it breaks the sound barrier, you heard the sonic boom. It's almost like the earthquake version of a supersonic jet. It's crazy. So in 2019, you see the article here, the scientists started warning it could mean the hazard of this whole region is underestimated, right? Why? Because before Palu, many researchers thought that super-shear ruptures mostly needed very straight, simple faults. But Palu was not that simple, right? That's why it was like, oopsie, surprise. The fault had bends, complexity, and segmentation, yet it still produced that high-speed rupture. So that means other complex strike-slip faults, hint, San Andreas Fault around the world and others may also be more capable of extreme rupture speeds than previously believed. So again, in the end screen for California, 2 faults can rupture together, and not what they recently found that Cascadia Fault and San Andreas Fault have, with evidence, triggered each other in the past. No, there's another fault that can trigger at a junction. And that would be so bad for Southern California. You have to watch that video because I bet you didn't know about that. But again, let's get back to this because there's more to this today's 6.7 and the aftershocks. So I'm showing you the aftershocks here. I'm showing you the region where this is happening. So shortly after, the first aftershock happened already, like the 5.2. But there's way more aftershocks happening there, right? So again, we have seen it in 2011 in Japan. We had a 7.4 something that was an aftershock to a big megathrust earthquake, right? So 7.4, 2018. So this could still be a foreshock. It could. We don't know. It's hard to say. We have to watch what's happening over time. So 27 miles east-southeast of Palu, same broader disaster zone at only 6 miles deep. That is shallow. Shallow earthquakes are dangerous because the energy has less distance to weaken before it reaches the surface. But the important difference, 2018 disaster was mainly strike slip. Ground tore sideways along the Palu-Koro Fault. Today's beach ball, we've looked at it, shows something different. The moment tensor faults points to normal faulting. That means the crust was pulling apart and one block dropped basically down relative to the other. So this does not look like an exact repeat of the 2018 rupture. But again, data is preliminary, guys. Keep that in mind, right? So it seems that it's not the simple sideways tear. But even if it's not, stuff like that can trigger the main fault if it's close to being due. And we don't know if it's due, right? But and it's important that it happened inside the same highly stressed central Sulawesi deformation zone near one of Indonesia's most dangerous fault systems. And that is the real concern. Palu is not just sitting on one clean fault, it sits on a complex zone where strike slip motion, vertical movement, extension, offshore faulting, steep terrain, and Palu Bay all interact. And I haven't confirmed it yet, but I mentioned it, that water was receding and that there was something coming in, that they think there might have been a landslide that had been triggered by this earthquake, but I don't have that confirmed yet. But just for you to know. But the combination of that area is why earthquakes in this area can become so destructive. The 2018 event proved three terrifying things. First, the Palu-Koro system can produce a major disaster. Confirmed, check mark. Second, The rupture can move at extreme speed. Check mark, right? Third, the tsunami risk is not limited to classic subduction zone earthquakes. That is huge because normally we have high tsunami risk if the seafloor is displaced. If we have a subduction zone, one plate sinking underneath the other, it's slipping up, it's displacing a lot of water. Here, there was this massive tsunami from a strike-slip fault in 2018, right? So strike-slip fault helped to produce a tsunami in Palu Bay, likely through the combination of seafloor movement, coastal landslides, probably responsible for this, and the shape, the geological shape of that bay that was amplifying the water. So this is why this new shallow 6.7 near Palu is catching our attention, I have to say, right? Doesn't guarantee another 2018 event, it does not. But it shows that this disaster zone is quite active. Still active, it is active. That's what we have to say. And the mechanism tells us that the crust is not only sliding sideways in this region, parts of it are also like opening and dropping. And that is exactly the kind of complexity that makes central Sulawesi so hard to judge. The question now is not only was this an aftershock of maybe something that happened in the Philippines? No, it was not. Or is this a foreshock? The big question is, did this quake or does this quake change stress nearby on other faults? Could it trigger something else? Did it disturb part of the Palu-Koro system, the dangerous one? And are aftershocks now migrating towards more dangerous segments? Right now, we don't have certain proof that a larger earthquake is coming, right? But Palu, really, I want to make that clear, is one of the places where even a single shallow quake deserves our really attention because history already has proven that this is a earthquake war zone, so to speak, and what it can do, how the rupture can accelerate, right? So in 2018, not just a normal shaking, tore at extreme speed, triggered landslide, helped send water into the city in form of a tsunami. And it has turned Palu in one of the most studied earthquake disasters in modern Indonesia. We also have to say that, 2018, right? So now a new strong earthquake has struck nearby, different mechanism as it seems for now, but same dangerous region. And the warning that was given in 2019 is valid right now. It's still valid, right? So the takeaway is the next big rupture may not behave like people expect. Of course, I will keep you updated. And as I mentioned, check out these videos here in the end screen. Absolutely crazy. What is looming over California? Really, you need to know that because this is something that hasn't been reported previously. So check this out. I'll see you there. Bye-bye.